everyone, in today's video we are doing a tutorial on using Matplotlib Python library to create more advanced visualizations like stacked bar charts, heat maps, and subplots. Now this is part 2 of my 2-part Matplotlib series. In the first part we went over how to create simple visualizations like line charts, bar charts, scatter plots, and box plots. So if you want to check that out, I'll link it up here, but it's on my channel as well. Alright, so we'll get right into Jupyter Notebook and I'll do a little bit of a review of the data set and kind of the cleaning steps we went over in the last video. The first thing we needed to do is our import statements, so we imported pandas and matplotlib. Here we're reading in our data set. It's split up into 3 different CSV files, so we read them in separately and then we join them together. Just a reminder from the last video, this is what this data set contains. This is a retail sales data set and it contains weekly sales for multiple different stores and each department within that store. And then it also has some more macro information about what was going on during that week, like what the temperature was, what the fuel price was, if there were any markdowns on items, the consumer price index, unemployment, and whether or not that week contained a holiday. The first visualization we're going to start with is a stacked bar chart, and our use case for this is that we want to show the total number of sales for the year by department for each store. So each section of the bar chart will represent one department for that store. So the first thing we need to do is group our data frame by store and department so that we can get the total number of sales for the year. So we'll create a new data frame called complete dataset dedupe underscore department. We'll take our original data set and we will group it by store and by department. And then we'll subselect weekly sales because that's what we want to find the sum of. And then we'll also reset the index because right now store and department are the indexes and we just want those to be normal columns, not the index. And we'll also rename weekly sales to total sales just so that the name of the column correctly identifies that that's a sum of all the weekly sales for the year. So if we take a look at this, we'll see we have the total sales for each store and each department within that store. Now, if we were just making a normal bar chart, this type of data frame format would work. However, since we're doing a stacked bar chart, we actually need to pivot this table so that each department is its own column with a total sales value. This is because when Matplotlib creates a stacked bar chart, each section of that stacked bar chart needs to be its own column. So store 1, department 1, having a total sales of $900,000 needs to be in its own column. So we'll create a new variable called complete dataset dedupe department pivot, and that'll be equal to this grouped data frame. We'll run the pivot table function on the grouped data frame, and here we'll specify the index, which is store. We'll specify the columns as department, and our values are going to be total sales. And we'll also reset the index here so that store will be a column instead of the index. And if we take a look at this, we now have the pivoted table where the total sales of store 1 for department 1 is here, for department 2 for store 1, the total sales is listed here, and now Matplotlib will be able to use this to create these stacked bar charts. So to create the bar chart, the first thing we need to do is get the unique number of stores. So we can just take all the values of store from the pivot table. And so we'll just get a list of 1, 2, 3, 4, 5. And for a stacked bar chart, we need to track where each section of that stacked bar chart ends. And we can do that by tracking it in an array. So that's what we're doing here, where we're creating the bottom variable. And this variable will be an array of 5 zeros because that is the starting point of each of the bars in the stacked bar chart. Now here we have a 0 and then we're just multiplying it by the length of the pivot table, which is 5. So this bottom will actually contain an array of 5 zeros. All right, so now we need to do a for loop where we're going to loop through each of the columns in the pivot table. And we'll start with column 1 because column 0 is store and we want to skip that column and we just want to go through those departments 1, 2, 3, 4, 5. And for each department, we'll create a bar chart for all of the stores. So X will be equal to stores, and then we'll take the pivoted table and just take whatever value is at the department we're on. So in this first loop iteration, department will be equal to 1. So for each of the stores, we will plot whatever the total sales were for department 1 or column 1. We also need to specify bottom here. And since this is a stacked bar chart, we're going to need a legend to indicate what part of the bar corresponds with which department. So we'll set label equal to department. And the next thing we need to do is update this bottom array so that each of these array elements will be the next section where the next part of the bar chart needs to start. So all this does is it goes through each of these elements in bottom and it adds the value that we're seeing for that department. So let's say for store 1 and department 1, they had $100,000 in sales, right? So this element right now is 0. When this thing runs, this will update to 100,000 because the next section of the bar chart will have to start at a 100,000 Y value. And now I'm just going to add in some things for the X labels, Y labels, titles, the legends, the grid, and we'll do a tight layout here. And what this does is it makes sure that all the elements that we're adding, these labels, these titles, these legends, they're all spaced correctly so that nothing's overlapping and nothing's cut off. Okay, so now we see we have a stacked bar chart where each section of the bar chart corresponds to a different department showing its total sales. So blue is department 1, orange is department 2, and so on. Now you'll see that the axis here is in an exponential scale, and I think it's easier to have it as a decimal scale. So we can actually add in a specification for the y-axis. We'll do plt.tick label format, and we'll specify we want the format for the y-axis, and we want the style to be plain. And here you can see now we have a decimal scale y-axis. Now I know sometimes when this is being built, when I first learned this, I was a little bit confused as to how each of these bars got created. So I wanted to really quickly just walk through a couple of the for loops just to show how it works. So let's say we just go through columns 1 and we run it. You'll see that this is just for department 1, right? So department 1, if you remember earlier, let me actually print out the pivoted table. Department 1 for store 1 had like around 100,000 sales, like around 90,000. So you can see that's plotted here. And then for store 2, department 1 has 120,000, I believe. Oh no, almost 1.2 million. So that's plotted here. And you can see the same thing for department 1 for store 3, 4, and 5 as well. So now if we increase this to add in the next column, department 2, you'll see that department 2 is just added on top of this. So it went through each of these rows for column 2 as well. So I think walking through each of those loops kind of helps me understand the bar chart, how it's built better. So I just wanted to go over that really quick. But that's how you would create a bar chart, a stacked bar chart using Matplotlib. Now the next type of chart we want to create is a heat map. And for the heat map, we're going to use it to visualize the correlations between our weekly sales and those different macro columns like the temperature, the fuel price, the unemployment, and all of that. Now we're going to need NumPy here, so let's just import NumPy as NP. And then we'll specify the columns that we want for correlations. So that is going to be weekly sales, temperature, fuel price, CPI, and unemployment. We just want to see how these are correlated with each other. And we'll do a correlation matrix where we'll take our original deduped data set. We'll specify the columns that we want, and we'll just do core. And that will give us a correlation data frame. So here you can see how weekly sales is correlated with each of these features, and you can even see how, fuel price and temperature is correlated as well. So to create the heat map, we need to use the imshow function of Matplotlib, and here we'll just pass it our correlation matrix, and we can pass it a specific CMap. These are the different color maps that you can use. You'll see like blues and you'll see reds. We're going to use the red and blue one. And there's different values this can take, and you can Google the different CMap values that are there in Matplotlib. And if you've seen a heat map before, you'll see there's like a color bar on the side, and that generally has a range. So vmin and vmax are the parameters that we can use for the imShow function to set that. So we'll set vmin equal to -1, which means a -1 correlation, and vmax equal to 1, which is a very strong positive correlation. We also need to add the color bar onto here, so we'll use the color bar function, and we can set a label on that color bar as well. So we'll set that to correlation so that we know what the colors on the heat map are indicating. And let's set that font weight equal to bold. Next, let's set some X and Y ticks on here. So starting with X ticks, we can use the X function. And this is where NumPy comes in, so we're going to use a range and the length of all the columns. So we want 1 tick for each column that we have, and the names that they'll have will be the same as the column names. We'll rotate them 45 degrees, and we'll set font weight equal to bold. And then we can also set the alignment equal to right here. And we'll do almost the exact same thing for the Y ticks. The only difference is we won't rotate it and we won't align it. And I forgot to set the figure size earlier, so we'll do that as well, just so we get a good size figure. All right, and then I just added in a title and I added in the tight layout. And when we print this, we can see we have the heat map, and the stronger correlations like unemployment and CPI are shown in red if there's a strong positive correlation, and then if there's a negative correlation, that's shown in blue. So imShow is the function you need to use to create a heat map in Matplotlib. Now the last more advanced topic I want to go over in Matplotlib is the topic of subplots. So subplots are used when you want to show multiple graphs in one visualization or in one chart. Now this is generally used when you want to break up the charts by a certain grouping, or you want to show like a bar chart next to a scatter plot, something like that. And all a subplot really is it's Matplotlib dividing up the figure into a grid that has a certain number of rows and a certain number of columns, and you can go through each cell in the grid and determine what type of graph that cell has. So the first thing we're going to do is we're going to create 2 variables called fig and axis, and we're going to use the subplots function from Matplotlib, and we're going to specify the number of rows we want, which in this case is 1, and the number of columns we want, which in this case is 5. We can set fig size here, which will have that equal to a width of 20 and a height of 5, because we're going to have like a row of 5 different charts. And we're going to have share y equal to true. That means every single plot within this subplot will use the same y-axis. They won't have individual y-axes. And let me just really quickly review what we're actually creating with these subplots. I don't think I did that yet. Well, if you watched the last video, you might remember that we created a scatter plot of the weekly sales by the temperatures for all the stores. Well, what I want to do here is I want to actually split this chart up into individual scatter plots for each store showing the sales by temperature. And so that's why we're doing 5 columns, 1 for each store within 1 row. Now we want to go through each unique store in the data set. So we'll do for I and store type and enumerate the list of unique values. We'll take the subset of the data frame that we want, which is just the sales for one specific store. Now in this for loop, if you notice, we used enumerate and we didn't just loop through the unique list that this code generates, because we want each unique store, but we also want an index to go with that store, because this variable axis is also indexed. Axis at 0 is equivalent to that first cell in the subplot. Axis at 1 is equal to that second cell in the subplot. And we need to access that specific index of axes so that we can set the scatter plot at that cell specifically. So here, if we do axis at I, which for the first iteration will be axis at 0, we want to create the scatter plot for store 1 here, which is what we'll have in the subset. So we'll just do the scatter plot code. And I'm going to copy this over here. We have the X value as temperature and the Y value as weekly sales for our subset, so just for store 1. I'm setting the transparency of each point to 0.6 and the color to teal. I'm also going to set the title for this, and the function is a little bit different than when we're not using subplots. Instead of like plt.title, we actually do axis.setTitle. And here we'll give it a formatted string of store along with the actual store, a font size of 14 and a font weight of bold. We'll do a similar thing for the X label. And now instead of just X label, we'll use set X label. We'll set that to temperature. And we'll give it a font size of 12 just to make it a little bit smaller than the title. And since we're doing share y equals true, we really only need to set the y axis for the very first chart. So we only want to do a set y label if I is equal to 0, which means if we're only manipulating the first chart in this subplot. So let's do plt.show. And you'll see here we have different subplots of each store. So here, instead of everything on one chart, we have split it out by store so that each store has its own scatter plot of weekly sales by temperature. And you'll see we don't have a title on this. We can give this an overall title as well using the figures subtitle, which means super title function. And we'll set that to temperature versus weekly sales by store type. And we'll also make that a font size of 14 and a font weight of bold. And we can also do plt.title layout, just so everything is nicely formatted. All right, there you go. There are our subplots. Now, if you wanted like another row here, so if you had multiple rows and not just one, multiple rows and multiple columns, here you would do a nested for loop. So you do a for loop to go through all the rows, and then another for loop to go through all the columns. Then you'd index it with 2 indexes. So it would be I and then let's say J. All right, so that is it for our Matplotlib tutorial over how to create some more advanced visualizations. I hope this video was helpful for you. If you have any questions, please let me know in the comments below. I'll also link the datasets and a link to this notebook in the description of this video. Thank you so much for watching this video. If you liked it, please give it a thumbs up and please subscribe to the channel. Thanks again for watching, and I will see you in the next one.